Bismillahirrahmanirrahim. This lecture is related with the change of basis that leads to a new matrix representing a linear operator. So what does it mean? It means that if we have a linear operator in the space, for example R2 to R2, and we need to find its representation in some other basis t, because this representation is given in the natural basis form, and we can write the matrix of this representation in terms of the natural basis by applying L on the natural basis vectors, and the vectors obtained are written in the matrix form as a column, and this matrix L represents the matrix of this transformation. So what is this matrix L in terms of this basis vector? So this is the question of today's lecture. So in other words, if I put this problem, then I can say that if I am working in the T basis and you are working in the S basis and you are using some operator in S basis, so what do I call that operator in my language of basis T? So I simply interpret this matrix L into my language T. So for this, I have to do this circle. What does this circle represent? So if we have this vector x in your language S, and this L transforms this S into L of x, and this vector is again in your language S, and what I can do, I can convert this x into my language T by using this change of basis matrix, which we have done in the previous video. And what also I could do that is transform this vector into this vector in my language by again using the same matrix of change of basis from S to T. So how do I find the relationship from here to here? To find this relationship directly, I need to go back into your space. What I do, I go from this x to your x, and your x then maps onto your L of x by using your L, and then I transform L back into this space. So in this way, I can go from this space to this space. Now what does going from here to here means? It means that I have to find the basis matrix, the change of basis matrix from T space to S space. So definitely I can find it by doing here that if I know the change of basis matrix from T to S, which is very simple to write, as I told you that any of the bases can be easily transformed into the natural basis by just putting the vectors of T into the column. So the matrix change of basis matrix from T to S can be simply written as 1 minus 1 and 2 1. So if I call this vector, this matrix as A, then I see here that this is the matrix A, this is the matrix L, that is going from here to here is the matrix A, and then going from here to here is the matrix L, and then going from here to here is the matrix A inverse, because both of these matrices are inverse of each other. So I apply P from T to S on this vector X, which is in my language, then apply L on these two, and then I apply the matrix P from S to T on these two. So I can write it as A inverse L of A, and hence what I obtain here, that L in your language S is equals to A inverse LA in my language D. So this is it. This is a very short topic but very easy. If you understand the topic of change of basis matrix, then this topic is very easy for you because it's totally based upon that lecture. So you can go and you can see the videos related to the change of basis matrix. That video is in two parts. You have to see the both of the parts and then you would be able to understand this lecture. Thank you very much.